Good day, everyone. For today's experiment, we will perform experiment 6, which is the energy conservation using projectile launcher. The objective of this experiment is to show that the kinetic energy of the ball launched straight up is transformed into potential energy. So, what is energy? So, energy is a property of any object or any mass that enables it to do work. For this topic, we will just talk for mechanical energies. In this energy, these are energies that due to position of an object or movement of an object. So, we are talking about potential energy and kinetic energy. So, kinetic energy is the energy of motion. So, it means if we will solve for the kinetic energy, velocity is involved because it will describe the motion of the object. While potential energy is the energy that something possess or that the mass possess because of its position respect to the ground. So, therefore, for potential energy, this is not an energy at rest, but this is an energy due to its position. So the variable that is involved here is the height. Potential energy has a symbol of U that is equal to mass times the acceleration due to gravity times its height. So from this picture, so it will just show you that whatever the path of the object, it will just have the same potential energy because the final height of these objects are just the same, which is 3 meters. Now, from this formula, we will have the unit for energy, which is kilogram, that is for the mass. For the acceleration due to gravity, so the unit of that is meter per second squared, and the unit of height is meter. So if we will simplify this more, so that will be kilogram meter squared over second squared, or the equivalent of this is just joule. For kinetic energy, so this is the energy in motion. So it involves velocity, as I said. So the formula of this is 1/2 times its mass times its velocity squared. So the unit of this is kilogram meter squared over second squared, which is the same here. So therefore, this is also joule. Now, we will talk about the conservation of energy for this experiment. It says that energy cannot be created nor destroyed. It may be just transformed from one form into another, but the total amount of energy never changes in our system. So, as the object moves downward, as you can see, some of the potential energy will be converted to kinetic energy until such that the object reaches the ground. Before it touches the ground, so the potential energy is 0 and the kinetic energy is the maximum here. So it means the energy will just be transformed from one form into another form. So let's say this is the start of the position of our object, and this is the final point of our object. So it means, so this is the initial point. We have here the initial kinetic energy and the initial potential energy. While for this point, we have the final kinetic energy and the final potential energy. According to the conservation of energy, whatever the energy before should be equal to the energy after. So that is the total energy before, it's just equal to the total energy after. So it means we have the kinetic energy initial plus potential energy initial is just equal to the final kinetic energy plus the final potential energy. So if we will substitute the formula of kinetic energy and potential energy that we have discussed before, so it means this is 1/2 mvi squared plus mgyi is equal to 1/2 mvf squared plus mgyf. So this is the formula for the conservation of energy. So let's talk about our experiment. So we will use a projectile launcher. So the object will start here at this point, and we will prove that the conservation of energy from the object that starts here going here is just converted into another form. So at this point, we will assume this is our initial point, so that is 0 meters, and the position where, based on the idea of free fall, as the object goes to its maximum height, the object will stop. So since the object stops at maximum height, so the final velocity is 0. So we will get that maximum height Okay, so here, so we will have the initial kinetic energy and its potential energy. Well, for this point, we will get final kinetic energy and we will also have the final potential energy. So we will use the energy conservation formula, and from here, we have to determine the mass of the ball, and based on the formula, we also have to get what is the initial velocity of the ball before it goes up. And from here, we will also have the initial height. So since this is assigned as 0, so it means our initial height is 0. Based on the idea of free fall, as the object goes to its maximum height, the final velocity is 0. And we will also determine the height at this point. So since we have two variables that is equal to 0 here, so it will be just this one. So it will be the initial potential energy and the final kinetic energy will be cancelled out. So it means we will compare the initial kinetic energy to the final potential energy, and it means our initial energy here will be the kinetic energy and our final energy here will be represented by the potential energy. So from this, let's try to do the experiment. So first, you have to get the mass of the ball. Second, you have to get the y average of the ball as you use the projectile launcher, hit it upward. So you will do this for 3 trials to get the y average. And you will have to also to get the initial velocity of the ball as it goes up. If you already determine the average height, you can now solve for the final potential energy. And if you determine the initial velocity, you can solve now for the initial kinetic energy. Let's focus first on how to get the initial velocity. So we will use the idea of the projectile motion to get the initial velocity of an object. Since the projectile launchers applied constant force on the ball, so whatever the orientation of our projectile launcher, it's either vertical, horizontal, or all with angle, the initial velocity is just the same. So it means we will use the idea of projectile motion to get its initial velocity. So if this is the ball, and our projectile launcher is just oriented horizontally, so this is the velocity or the velocity on horizontal or Vx, and this Vx is also just equal to the initial velocity that we are looking for. So based on the projectile motion, initial velocity is just equal to the average range, which is this, where the object will drop, divided by the time. And the time here, we will not use a stopwatch or any device to get the time. We will use the height to solve for the time. This can be determined again using the formula for projectile motion, in which if you are going to find the time using the height, it will be just time is just equal to the square root of 2y divided by the acceleration due to gravity. And note that the acceleration due to gravity is 9.8 meter per second squared. It means to get the initial velocity, we have to measure the height from the center of the ball to the ground. And we are going to also to measure the range from this point going to the point where the ball hit the ground. So to determine the range, we will use a paper, and on the top of the paper we will have the carbon. So as the ball hit the floor, so it will produce a mark on our paper because there is a carbon, and we will measure that mark from the end or from the mouth of the launcher to the mark on the paper. So it will be just like this. So this is our carbon or the paper itself. And for example, this is for the first trial. So we will measure the distance from this point to our mark. So we will call this as x1 or the range 1 for first trial. If we will do the same for the second trial, so we will have a mark again, and we will call this as x2. And for the third trial, we will have a mark again, and we will get x3. So as much as possible, the difference of these marks are not greater than 2 or 3 cm to each other. So for your data, so you will place your value for your trial 1 on this. So that is x1. Here is for x2. This is for x3, and you will get the average range or the horizontal distance. To get the average range, it will be just, you will add the 3 values divided by 3. So again, to solve for the initial velocity, we have to get the average range divided by the time. So we have the average range now. And for the time, we will just have 2y over g, in which we will just determine the value of the height from the center of the ball to the ground. So that is our y, or the vertical distance. And g is equal to 9.8 meter per second squared. So it means, be mindful that the distance should be in meters. Once you get the x average and you also determine the time, we can now solve for the kinetic energy. So that is 1/2 mv I squared. And to solve for our potential energy, so we will just get for the height. So this is the start. So that is our x0. So we will get the height from the mouth of the launcher to the maximum height. So you will do this also for 3 trials. So we will have the maximum height for trial 1, maximum height trial 2, and for trial 3. And to get the average for the maximum height, so we will just add the 3 values divided by 3. And once you get this one, you can now solve for the potential energy, the final potential energy, in which that is mass times the acceleration due to gravity times the average maximum height. And we will now proceed for table 3. So once you have completed the table, the mass of the ball, the initial kinetic energy, the final potential energy, we will get the percentage difference, because we assume that these two values are equal based on the idea of the conservation of energy, in which to get the percentage difference of these two, since we know that kinetic energy is just equal to initial energy, and the final potential energy is just equal to the final energy. So it means difference is just equal to the difference of the two, initial energy minus final energy, divided by the average of that. So that is initial energy plus the final energy divided by 2. Absolute, it means it's always positive, times 100. So you will get the percentage difference. Okay, so that is for our experiment for today. So do not forget also to answer page 66 and 67 of your experiment. You also have to attach another paper for all the variables that you have solved to this experiment. Okay, so that is for our experiment 6, which is the energy conservation using projectile launcher.